We're going to be talking about sequences. Sequences are, exactly what you think of a sequence, but specifically in math, a sequence is a sequence of numbers that are connected by some sort of pattern. We're going to hone in on two specific patterns, arithmetic sequences and geometric sequences, which are each a little bit different. And so our sequences are either going to be arithmetic, geometric, or if they don't follow either of those patterns that we talked about today, we consider them to be neither. Okay, so an arithmetic sequence is a sequence of numbers in which a positive or negative constant is added to each term to produce the next term. And we call that constant that's being added each time the common difference, the positive or negative constant added to produce the next term. Okay, so let's look at our first example, 11, 9, 7, 5. So each time 11 to 9, then 9 to 7, then 7 to 5, you should be able to see that we are subtracting by 2 to get each subsequent term in the sequence. So since we're subtracting by that same number, that would make this arithmetic. And we say subtracting by 2 or in terms of our d, because remember d is a positive or negative constant that's always added, we would instead say adding by -2. So our d would be -2. Okay, so d is always added, but if it looks like we're subtracting each time, we're just adding by a negative. Okay. So number 2, consider the sequence below, 25, 12.5, 0, -12.5. So each time, okay, 25 to 12.5, that one kind of looks like we divide by 2 at first, but then we go from 12.5 to 0. Well, now we're not dividing by 2. Now we can see that instead we're subtracting by 12.5 each time. So minus 12.5, minus 12.5, and minus 12.5. So it's important to compare what's happening between each of the terms when considering the type of sequence. So since we can see that we're always subtracting by 12.5, we can say that as, just like we did last time, instead of subtracting by 12.5, that we are adding by -12.5, which means d would be -12.5, that common difference in between terms. Okay. Our next sequence that we're going to look at is what we call a geometric sequence, a sequence of numbers in which you multiply each term by a constant. Okay. So with arithmetic, we're adding. Geometric, we're multiplying. Okay. So that's the big difference between the two. And that term that we're multiplying, that's called our common ratio, the integer or fraction constant that's multiplied each time to produce the next term. Okay, so consider the sequence below, 2, 4, 8, 16. So you should be able to see that each time I'm doubling, which the only thing that would double it is if I was multiplying these numbers by 2. So if I'm multiplying by 2, that is what's happening. So our R value would just be 2, because I'm multiplying by a constant value of 2 each time in between terms. All right, now let's look at the sequence 4. This one's a little harder. We go 9, -3, 1, negative, and it looks like our fraction didn't come in the way we wanted to.
If you were saying,
but it should be -1/3 there. So we're going from 9, -3, 1 to -1/3. Okay, so this one's a little bit harder. We're changing signs each time. So if we're changing signs, we're going from positive to negative, then whatever number I'm multiplying by has to be a negative. And this is also a dead giveaway if I'm changing signs each time, that it's probably a geometric sequence, because the only way I could change a number's sign back and forth each time is if I'm multiplying by a negative. So that gives it away that it is a geometric sequence. The other way that we can check, and this is also a good way to determine what the ratio is we can take two numbers and we can divide them. So we want to take the second term and divide it by the first term. So -3, wrong color. -3 divided by 9, that would reduce to -1/3. third. Okay, so right now, to go from -3 to 9, I would have to multiply by -1/3, or what's probably a little easier to think about, dividing by -3. Just to check that this holds true for all of my terms, I can take the next two terms and do the same thing. So 1 divided by -3, which is also equal to -1/3. Okay, so the same thing is holding true. So each time I am multiplying by -1/3. And that holds true for my last one because 1 times -1/3 would make it into -1/3. And because it's negative, like we said earlier, it's going to switch signs each time. So what is happening? We are dividing by -3, or the way we actually want to reference it for r, multiplying by -1/3, and that would be our r value, -1/3. Okay, so that's probably the hardest one, is if it's a geometric sequence and we are dividing, the number is getting smaller. We have to make sure that we change the r value into a fraction. So r is equal to -1/3 instead of r is equal to -3, because if you say r is equal to -3, then you're meaning we're multiplying by -3 instead of dividing by -3. So that can be confusing. But identifying the different sequences just takes a little bit of practice, being able to see the terms. Okay, that nice little check there for geometric. You can do the same thing for arithmetic by just subtracting the two terms and seeing if that common difference holds true. And once again, if you tried to subtract these ones, then you wouldn't have the same common difference. If you tried to divide these two sequences, you wouldn't get the same common ratio. So that's how you know they're not arithmetic or not geometric, and vice versa. Well, that is sequences, y'all. Go ahead and work through the Nearpod and then complete the Desmos for homework.